All right, one of the other arithmetic operators in Java is the modulus operator. And it's something that you're not used to using in regular math, but it's something that comes up a lot. It's something that winds up being really useful. Now, back when we did like old school division, like long division, 11 divided by 2, well, 2 goes into 11 5 times evenly. So we would always put a 5 right here. And we would do 5 times 10 is 5 times 2 is 10, and then there's 1 left over. Okay, that's the remainder. So 5 would be our quotient, 1 would be our remainder. Well, in Java, when we do 11 divided by 2, remember, it doesn't give us 5.5. It gives us 5. So it gives us just the quotient. And then 11 modulus 2 gives us our remainder, which is 1. Okay. So, for example, if I did, let's say we did 23 divided by 5. Well, 5's going to go in there evenly 4 times, which gives us 20. So the remainder will be 3. Which means if I do 23 divided by 5, both as ints, it's going to just give me the quotient. It's just going to give me 4. And if I do 23 mod 5, it's going to give me 3. And this winds up having really lots of different applications here. So one of them is it helps determine even or odd. There's a lot of situations where that winds up being useful. So modulus 2 will be 0. Nothing will be left over when you do mod 2 if it's even. If it's odd, 1 will be left over. So mod 2 of whatever number will be 1. It can determine divisibility. Again, it'll return 0 if you're dividing it, if you're doing modulus by something that it's divisible by. It models cyclical behavior. The reason that is like, for example, 0 mod 3 is 0. 1 mod 3 is 1. 2 mod 3 is 2. 3 mod 3 is 0, because 3 divided by 3 has no remainder. 4 mod 3 is 1. And then 5 mod 3 would be 2. So it's 0, 1, 2. 0, 1, 2. It has this cycle. So anything that has this cyclical behavior, you can do all this really tricky coding, or you can just use modulus to model that cycle that's happening. So another interesting thing that it does is it can chop off digits. It can isolate digits. So if you do modulus 10, it's going to give you that last digit. If you do modulus 100, it's going to give you the last 2 digits. Modulus 1000 is the last 3 digits, and so on. If you do integer division by 10, it's going to chop off that last digit and give you everything else. So let's say we did 1, 2, 3, 4 divided by 10. Well, that's going to give me 123. And if I do 1, 2, 3, 4 modulus 10, well, that's going to give me that last digit. So this can be useful in situations where you're trying to isolate digits of a multi-digit number. So got all sorts of different stuff that can do for us.